Hey guys, my name is Danny Zuniga. I'm participating in Challenge 2014, and this is going to be make a video for quiz number 4. So what the problem asked, I didn't write down the instructions, but it asked to maximize the area of a figure that is a rectangle with a top that resembles a semicircle. So that's what I drew here. And it gives you that the perimeter is 4. So knowing that the perimeter is 4, we're going to start off by creating, by defining one variable in terms of another in order to not have two variables later in our area function, which is going to be happening down here. So here we're going to be looking at the area function. So we see that in the area function we have length, width, and radius. But I didn't write the radius down because the radius of the circle is going to be the same as w over 2. So we see that we have a function here in two variables. So what we're trying to do is make this L, define this L in terms of w, that way we can plug it in and we can have straight w's in this function, and then we can solve for w, and then we can plug that back into our equations and find the other dimensions. So we do that by using our given, our only given, which is that the perimeter is 4, and we know that the perimeter is the width here plus both lengths plus the perimeter of the outside, which is 2 pi r over 2, because a circle is 2 pi r, but this is a semicircle, so you have to divide by 2. And then we substitute in w over 2 for r, because it's made obvious here, if this is w, then that's your diameter, so then r is that divided by 2, so it's w over 2. So now you have your length. You have 4 equals w plus 2l plus pi times w over 2. So now you can solve for L by moving the w and the pi times w over 2 to the 4 side. So 4 minus w minus pi times w over 2, and then dividing by the 2 in front of the L. So divided by 2. So now your L is going to be defined as this function right here. 2 minus w over 2 minus pi times w over 4. Then you're going to use this to plug into this function right here for our area formula. So now instead of L, we're going to have 2 minus w over 2 minus pi w over 4, and then we're going to keep the rest. So L, that was L, now it's w. So just times w, and then plus pi w squared. And we have over 8, because area is length times width. Area is going to be the area of this rectangle, and then the area of the semicircle. So this was a rectangle. Now the semicircle is pi r squared over 2, and we know that r is w over 2, and it's pi r squared over 2 because it's a semicircle, so you have to divide by 2. So we have that here, and since you're dividing by 2 and you're squaring here, what's going to end up having is going to be w squared over 4, and then you divide that by 2, so it's the same as multiplying by a half, so 4 times 2 is 8, so that's why you get the denominator of 8. And now we distribute that w into each of these 3 terms, and we get 2w minus w squared over 2 minus w squared times pi over 4, and then we just put the pi with the w here from there, another kind of distribution. So, and now we have, I saw that these two were pretty similar, they just have a different denominator by a factor of 2. So I multiply by 2 here, multiply by 2 here, then it's negative 2w squared pi plus w squared pi, so you get a negative w squared pi. I just rearranged it over 8, and then you keep this term. And then from there, I got my w squared terms, and I combined the numbers in front. So both of them are w squared over 8, so I factored that out, and then I put the remainder in parentheses here. So it was negative pi plus 4, because they're both negative, so the negatives make both of these negative, and then you keep the 2w. So now you have your square terms grouped together and your degree of 1 terms grouped together. And now from there I can derive a, because by deriving a, we're going to find our maximum by setting the derivative equal to 0. So that's what I did here, equal to 0, that's what it says there. So by setting our derivative equal to 0, we're going to find our maximum points. So here we set it equal to 0 and I move the 2 over. This plus 2, I put it minus 2 on both sides, and now we just have this w term now because it was w squared, but now we took the derivative, so now it's just w. Took the derivative to w, now it's just 2, that's how this got to this. So now we just have this right here, negative 2 equals negative 5 plus 4 times w over 4. So now if you can see this as negative w plus 4 over 4 times w, negative pi plus 4 over 4 times w. So you can multiply by the inverse and go negative 2 times 4, which is 8. I'm sorry, negative 2 times negative 4, because you can't forget that negative right there in front of this. So now it's positive 8, and then you divide it by the pi plus 4. So w is that. So pi, this is like the correct answer, but to make it a little bit simpler, I made the dimension. I just plugged into the calculator and I figured out what that was. 8 divided by pi plus 4, and it's 1.12. And then you find the radius by plugging into your radius equals w over 2 function that we defined earlier. Up there, radius equals w over 2. So 1.12 over 2 is 0.56. And then for length, you plug into either of these formulas that you found earlier where you defined your variable. You can plug your w into either one, and your result would be 0.56. And now to answer the final question, it says what's the maximum area you can get by plugging these three values into my area function, length times width plus pi r squared over 2, because now we can use r because we know what r is right here. Then you get your area is 1.61 units cubed, and that's the maximum area you can make with given a perimeter of 4 for this shape.